One of the most important phase in the data warehousing process is the ETL phase, and we perform this ETL process at multiple stages. For example, when we load the data inside the staging database and when we load the data from the staging to the data warehouse itself, and when we are constructing multiple data marts from the data warehouse. In this video, we are going to have a look on some of the most important data transformation methods that we use to perform this ETL process. It means we are focusing on the T of the ETL process. Let's discuss all of these methods one by one in detail. So the first one is data joining. When we perform this ETL process, we are loading the data from a couple of various sources. For example, we have CSV files, we have a couple of different databases or cloud data warehouses, and this means we need to join the related data from different sources. For example, in this case, we have two tables coming from different sources, but they are joined by the customer ID. So the information is partially located in one table and partially in the other. So we use customer ID to join the data, and that's how we combine the data and then we load it inside the data warehouse. And this method is being performed when we load the data into the data warehouse itself from the staging area. Keep in mind that generally we load the data from the source systems into the staging as the first step, and we do not perform much of the ETL tasks in this process. And most, like 80% or 90% of the ETL transformation tasks are being performed when we load the data from the staging database to the data warehouse itself. That's where the games becomes interesting. So the next one is data deduplication. So one of the important goal of the data warehousing process or the data warehouse is to remove duplicates, to have only important and consistent and relevant information. So for example, we have one table on the right hand side which is the target. We need to load the data from the source to the target, and we have three new records, but we can see two of the records they already match. It means this is going to be a redundant data, so we're not going to add this one, but we add the two new records which are completely unique inside the data target. So what that means is we're going to have a check on the target data warehouse before we load the data, because we do not want to have duplicates in the first place. And this is also performed when we load the data from the staging to the data warehouse. Then we have keys restructuring. So this basically means, for example, we have primary keys, and in some of the cases some of the source systems have primary keys as a combination of different characters, and this combination is very meaningful. For example, in this case we have the first one as 23/02/1985, so this is like 23rd day of the second month of 1985. This is meaningful, and we do not want to have meaningful primary keys because it's expensive when it comes to data joining, and this information can get obsolete with time, and this is also difficult to pass on to the new data warehouse developers because we do not want to have any knowledge or information inside the primary keys. This should always be like surrogate keys. They should always be meaningless and simple. So the conversion of such complex keys to normal keys, this is also one of the parts of this ETL process. And then we have data cleansing, very important. We want to have clean data, complete, very accurate and consistent data, and we want to delete out of date data and the one which do not have valid relationships with other database tables, and we need to have a check before we load the data inside the data warehouse. We should have all that business logic inside the ETL process, and this is going to be covered inside this transformation tasks. And then we need to fix the syntax errors and typos and everything. Keep in mind, when we insert the data inside the data warehouse, then we cannot edit or update that data there are only two possible operations on the data warehouse. One is insert and second is read. This is going to be historical. It's not allowed to touch the data warehouse to update information, so we need to make sure that we perform all of these checks beforehand. And this also comes in the same place like the other ones as I explained previously. Then we have data validation. So two main categories include range checks and type checks. So we need to see if the numbers are in the right ranges or maybe the right data type. So if this is not the case, we need to correct it. We need to have algorithms, and then we load the data. For example, we have different numerical values or floating point values, and we do not allow some specific ranges or well the values beyond those ranges, so we're going to get these errors like this. So this is a snapshot when we load the data inside the OLTP system, and the best way not to have much errors in the data warehouse is to stop these problems in the OLTP systems where we are doing all those transactions in the databases. So if we stop these problems there, we're not going to have it in the ETL. But if we do not stop it there, then during ETL process we need to incorporate all these rules as part of the ETL logic. And yeah, for example, we could have time issues. We need to make sure this is correct, consistent and valid, and this is also being considered when we load into the data warehouse. So keep in mind there are going to be very less tasks that we will be performing while loading the data inside the staging database, and most of them in the second part, because staging is simply just like consolidating things from different sources to one database. So we create multiple tables inside the staging database, and then we do not perform any complex transformation tasks. But there could be some of the tasks. We're going to have a look on one of it afterwards. So the next one is data format revision. So when we load data from different data sources, and that's, I would say, always the case while performing the data warehousing process or data warehousing projects. So every database or every data source have their own naming conventions or own data format conventions. For example, some of them write mail with the complete MALE. Some of them are going to have only M capital, some have only M small letter. So and similarly date, it comes in different formats. So in the data warehouse we need to consolidate it and we need to standardize it before inserting. For example, mail, M as the capital letter and then the rest, and then we have date of birth also being standardized. So we need to make sure we standardize everything before loading data into the data warehouse. And yeah, this is a sample example that we could have the phone numbers and the dates in multiple various formats, and there can be hundreds of different variations. So we need to avoid these things. We need to know, we need to standardize before loading the data inside the data warehouse. And this also comes in the same place like others. Then data derivation. So for example, we have customer name and customer date of birth in one database table. We want to calculate the age, so this is going to be a derived attribute. We do not have all of the attributes beforehand, so some of them for sure they needed to be generated from other columns. For example, current date minus the customer's date of birth is going to be the customer's age. And yeah, this is how the derived attributes work. And then we have data integration. So data integration is essentially already incorporated in all other transformation methods, and this means that we are reading the data from a variety of different sources. For example, we have databases or cloud databases, we have files, CSV, JSON, or Microsoft Excel files, or maybe we have some SaaS applications. So we load the data from all of them, and we have some joining attributes, some primary keys based on which the data relates with one another. And that's how we integrate it, because in data warehouse we consolidate everything from a variety of different sources. And then we have data filtering. So data filtering means maybe avoiding some of the columns and some of the rows that are not required for the data warehouse, but they were valid for the database at that time. So for example, if we are working on Microsoft Excel files, how do we filter? So we have a filter tab, we have a filter sort of function on the top, and we click on it, and then we see we can perform, for example, Q1 or quarter 1, quarter 2. We can select some of the data. It means we are filtering it and we are neglecting other data. Same goes for data warehouse. We do not want to have all of the data. It could be, for example, we only want to have some unique values from particular column or particular table, and maybe we want to filter by rows or columns. So this completely depends on the business use case, business requirements, but data filtering could be essential in some cases, and data filtering needs to be performed before we load the data in the staging database, because we do not want to have redundant data or duplicates inside the staging database. Well, not redundant in this case, but in this case we do not want to have non-required data inside the staging. We do not want to have, we do not want to load the database with something that we do not want. So we need to make sure, if it's possible before staging, we do it at that point. If not, then we load everything in staging and we do it in the data warehouse. But data filtering, in the best case, better to do it before loading the data in the staging database. And then we have data splitting. So data splitting means that we have one column which has a variety of different information, which has more information than required, and we are going to have multiple attributes created from that single attribute. And for example, in this case we take the address and we are going to create multiple columns from that single column, and we need to know the logic. For example, the values are comma separated, and some of the values are semicolon separated, so we need to know this logic information beforehand, and then we perform this. And keep in mind, the databases are generally normalized and data warehouses are generally denormalized, so we want to have as much information in the data warehouse as we can, and as much columns as we can, because we want to avoid the joins. And that's why we do not want to store address like one column, because then we need to split it at runtime by the data visualization tools or query tools. So we're going to create all those columns which are required right away before loading the data in the data warehouse. And yeah, in the best case, these problems can be resolved in the OLTP systems, where we can have multiple fields for the multiple address fields for the entire address. And this comes at the ETL in between staging and the data warehouse. So thanks a lot for watching the video.